Imagine you pour sand into a cup of water by mistake. How do you get the sand out? You don't pour away the water. Instead, you find a way to separate them. That's exactly what chemists do. And today we are going to be covering the different separation techniques you need to know. Hi, my name is Rachel and welcome back to my chemistry lessons. Before we get into the techniques, let's talk about what mixtures are. So mixtures are combinations of two or more substances that are not chemically combined. So because there is no chemical reaction between the substances, they can be pulled apart, they can be separated using physical methods. And these physical methods are what we refer to as the separation techniques. Now, the technique you choose depends on the properties of the components in the mixture. So these physical methods, they each are dependent on the properties of the component, that is the properties of the substances in the mixture. So I've grouped all the techniques into what you are trying to separate because it's easier to remember that way, and that is how exam questions are structured. So let's take them group by group. The first group involves separating solids of different sizes. And the technique used in this group is sieving. So the principle behind sieving is purely about particle size. When you have a mixture of solids with different particle sizes, you use sieving. An example of this is separating gravel from sand. Another example is separating fine flour from lumpy flour in the kitchen. Group 2 involves separating magnetic solids from non-magnetic ones. And the technique used in this group is magnetic separation. So if one component in the mixture is magnetic and the other isn't, this makes it very straightforward. So if you pass a magnet over this mixture, you would see that the magnetic component will stick to the magnet and it will leave the rest behind. A common example of this is the mixture of iron filings and sulfur powder. The iron filings are magnetic, but sulfur powder isn't. So when a magnet is passed over this mixture, the iron filings are attracted to the magnet and it leaves the sulfur powder behind. So that makes the two components separated. Group 3 involves separating solids that sublime from other solids. And the technique used is sublimation. So when some solids are heated, they turn directly into gas without passing through a liquid phase. And this process is known as sublimation. So if I have a mixture where one solid is sublimable and the other isn't, what I simply have to do is to heat up that mixture, and then the sublimable solid vaporizes and the other solid is left behind. So to collect it, the vapor is cooled on a cold surface. Some examples of sublimable solids include iodine, ammonium chloride, and naphthalene. Let's say I want to separate ammonium chloride from sand. What do? I simply heat up this mixture and then the ammonium chloride sublimes. This vapor is then collected on a cool surface above while the sand is left behind. Group 4 involves separating an insoluble solid from a liquid, and the techniques used in this group are decantation, filtration, and centrifugation. So let's take them one by one, starting with decantation. In this technique, if a solid is dense enough to settle at the bottom, we say it sediments. So we can simply pour out the liquid and then the solid is left behind. Decantation is the quickest method but only works when the solid has completely settled. Number 2, filtration. This is the most common method in this group. So when we have a mixture of an insoluble solid and a liquid, this mixture is poured into a filter paper which is in a funnel. The liquid that passes through this filter paper is called the filtrate, and the solid that is left behind is called the residue. This technique is applied in industrial water treatment where solids are supposed to be separated from water so that the water can be pure. The third technique is centrifugation, and this is applied when the particles are too fine to settle or filter easily. The centrifuge spins the mixture at a very high speed, and this forces the denser solid particles to the bottom. Group 5 involves separating a soluble solid from a solution, and the techniques in this group are evaporation, crystallization, fractional crystallization, and precipitation. So let's start with evaporation. If you want to remove the liquid, which is the solvent, and recover the solute, which is the solid, all you have to do is to heat up the mixture and the liquid is evaporated off. But this only works when the solid is not affected by heat or it doesn't decompose when heated. If it does, you need a gentler method, which is crystallization. Crystallization can be referred to as a gentler method or a calmer version of evaporation. So in this technique, you heat the solution to evaporate some of the water and allow it to cool slowly. As it cools, the solute comes out of the solution and forms crystals, hence the name crystallization. These crystals are then filtered off and dried. The third technique is fractional crystallization, and this is used when we have two or more solids in a solution with different solubilities at different temperatures. I'll explain. So I have solid A and solid B. They are dissolved into a solution. Now, solid A dissolved at 30 degrees Celsius, while solid B dissolved at 50 degrees Celsius. That is what I mean by it has different solubilities at different temperatures. So by controlling the temperature, we can get one solid to crystallize out while the other still remains dissolved. And this is a more advanced version of crystallization. This technique, as well as crystallization, gives you a purer version of the product because impurities tend to stay in the solution. The last technique in this group is precipitation. In this technique, a difference in the solubility of a solid in two different miscible liquids is used to precipitate the solid when it is dissolved in one of them. For example, iron tetraoxosulfate 6 is soluble in water, but it is not soluble in ethanol. If a mixture of iron tetraoxosulfate 6 and water, I have it here, but I need to get that iron tetraoxosulfate 6 out, what do? I simply introduce ethanol. Ethanol and water are miscible, but ethanol isn't miscible with the iron tetraoxosulfate 6. So once I introduce ethanol into the mixture, a precipitate is formed because the iron tetraoxosulfate 6 now becomes difficult to remain soluble in the solution because of the ethanol that was introduced, and this forms a precipitate. So the precipitate is then filtered off and you have your iron tetraoxosulfate 6. Group 6 involves separating liquids. So there are three different techniques used in this group, which are distillation, fractional distillation, and the use of a separating funnel. So let's start with distillation. For distillation, it involves separating a solvent from its solution. So how this works is that the solution is heated up and then the solvent evaporates. This vapor passes through a condenser where it cools and turns back into a liquid, and it is collected separately. So what's left in the flask is the solutes and other impurities. An example of this is obtaining pure water from salt water. The liquid that was gotten from passing the vapor through the condenser is called a distillate. Secondly, we have fractional distillation, and this is used to separate miscible liquids. Miscible liquids are liquids that are completely mixed with each other, like ethanol and water. So when the mixture is heated up, the component with the lower boiling point evaporates first and is then collected, which leaves behind the other components. The fractionating column helps achieve a better separation by allowing vapors to condense and re-evaporate multiple times. The most common application of this is the fractional distillation of crude oil, which produces petrol, kerosene, diesel, and some other components. Thirdly, we have separating funnel. So separating funnel is used to separate immiscible liquids, and immiscible liquids are liquids that do not mix at all, just like oil and water. So they form two distinct layers, and when this mixture is turned into a separating funnel, it is allowed to settle into these two distinct layers. The denser liquid is then drained out through the tap at the bottom, while the less dense layer remains behind. Another example of this is separating petrol and water. Because they have different densities, they can be separated using a separating funnel. The last group that we're going to be looking at is group 7, which involves the separating of solutes from a solution. And the technique used in this group is chromatography. Now there's gas chromatography and there's paper chromatography, but for this level we're just going to be dealing with the paper chromatography, specifically the ascending paper chromatography. So this works by getting a chromatographic strip, which is the stationary phase. Like we see here, the stationary phase is the paper. Then the solution containing the different solutes that we want to separate is then spotted on the chromatographic strip on one end of the chromatographic strip. So the spotted end of the strip is dipped into the appropriate solvent. The spot isn't dipped, but the spotted end is dipped into the solvent and is put into an airtight jar and closed. Once the strip is dipped into the solvent begins to travel along the strip, and that is what we refer to as the mobile phase. As we see here, the mobile phase is the solvent moving up the paper. So the solvent moves up the paper. As the solvent moves, the different solutes begin to travel up as well. And because they have different speeds, they begin to separate. So one solute from its spotted solution begins to travel up at a faster distance. The other solute follows, another solute follows, and that is how they begin to separate because of their different speeds. Like we see here, different components travel at different speeds, so they separate into different spots. Now, once all the solutes have completely separated, the strips can then be brought out from the airtight jar. Now, this RF we're seeing here is referred to as the retardation factor. And this retardation factor is used to identify components. And there's a formula for this. The formula is the distance traveled by the substance divided by the distance traveled by the solvent front. So let's solve this question quickly. Let's say you are given a question and then you've extracted the values. So the distance traveled by the substance is 4 centimeters and the distance traveled by the solvent front is 8 centimeters. What would be your RF? So your retardation factor will be 4 centimeters divided by 8 centimeters, and that will give you 0.5. So that's your answer, and it's that simple, literally. Let's quickly summarize everything that we've learned. So every separation technique that we've spoken about is based on the property that makes one component different from another, be it particle size, boiling point, miscibility, magnetism, solubility. These are all your decision points. Okay, if this video helped you, if you liked and learned something from this video, make sure you share it with your friends. Anyone you know will benefit from this video. Comment down below what you will want to see next. Make sure you subscribe and like this video, and I'll see you in our next lesson. Bye.